Hi, everyone, and welcome to the fourth webinar in our virtual classroom series. We've already talked about our release policy and patching process, upgrade, and performance stability. Today, we're going to take it a step further and prepare you for the future, the multi-tenant architecture.
The multi-tenant architecture brings many new great features to light. For instance, I'm absolutely sure that you will love the new feature, refreshable clone PDBs. But today we will focus entirely on the migration itself, which is just running a script, isn't it, Mike?
Yeah, sort of. But there's a bit more to consider. The migration may be just a script, but we want you to have the best migration. So we will also talk about data guard, fallback, transparent data encryption, different upgrade scenarios, and of course, we will talk about the pitfalls. So enjoy.
And since you've already heard a little bit from Daniel, let me introduce him properly. Daniel Overby Hansen is our cloud migration lead product manager for Oracle Database, and he's always up on the latest migration techniques and technologies, whether it's going to the cloud or on premises. So you really should make his blog a regular visit and follow him on Twitter.
This is Roy Swanger, and Roy is our Vice President for Database Upgrades, Utilities, which includes Data Pump and the SQL Loader and patching. Roy is based in New Hampshire on the east coast of the United States, approximately an hour north of Boston. And Roy will show you today that he loves tech. You'll find his Twitter handle on the slide here.
This is Mike. Mike is our go-to guy on anything that involves upgrades and migration. He has been with Oracle for so long that he talks about 8i as if it was just yesterday. All his extensive knowledge is stored on his blog, mydietrichde.com, which, by the way, should be on the top of your blog roll.
Before we start with the technical session, a few organizational things up front. As usual, you can download the slides already while we talk here from the database upgrade blog, mydietrichde.com/slides. Go to webinar 2021 and access the entire slide deck for today as PDF. Then the seminar will be recorded. So you will get access to the video recording as well. Feel free to share it with your teammates, with your friends, with family. And you will find the link to the video recording also on the upgrade blog, mydietrichde.com/videos. It usually takes 1 to 2 days until we can make the link available. Then questions. Very important. For questions, please use the Q&A in Zoom. Don't use the chat. Q&A, we will try to answer all your questions, and this gives us or you the possibility, if you would like to, you can do a copy-paste later on and preserve all the questions and answers for your own records. Then this seminar will be broadcasted in HD. This means if you have any problems with the resolution, please just disconnect from the Zoom session and reconnect again. Then it should work typically. And finally, for the agenda today, we have again an agenda, and this seminar will take approximately 120 minutes. We will do a break in the middle, 5-minute break. So then don't turn off, just refresh yourself, refill your glass, and then it goes on after 5 minutes. We will start with multi-tenant architecture. Then we would like to show you how to migrate a straightforward and simple way into the multi-tenant environment. The migration options, the different ones, which includes then also data pump, transportable tablespaces, and so on. Fallback options, very important. And then we increase the complexity a bit because we would like to show you what you need to take care of when you have a standby environment you would like to protect. Not to forget, transparent data encryption. And then we would like to show you, once you are in multi-tenant, what your upgrade options are and how quickly you can upgrade. Final pieces will be a quick sneak into patching time zones in multi-tenant environment, and then to finish that seminar, a customer example. So this is the plan for the next 120 minutes. Let's go forward here.
Before we get into actual nuts and bolts of migrating to the multi-tenant architecture, it's probably worth a quick recap of the basics of what this architecture means and why you should be thinking about migrating to it. This kind of ties into the first seminar in our series about release process and patching, and also the most recent one when we talked about deprecated versus desupported parameters. In the 21C documentation, you'll see this note saying that the non-CDB architecture was deprecated in Oracle Database 12C and that it is desupported as of 21C. What does that mean? Well, it means when 12C was released way back in January of 2014, believe it or not, 7 years ago, we did make clear that we were moving towards this multi-tenant architecture as the foundation for Oracle Database. So we've given 7 years of preparation and put in a lot of functional enhancements and so on into multi-tenant. And now with 21C, it's finally time to make that leap and make multi-tenant the one and only Oracle Database architecture. So what does that mean for you right now? Well, if you're going to 19C, just be aware that 19C does support the non-CDB architecture, but it is the last release that will support non-CDBs. And this means that, for example, when we migrate to 21C, you won't be upgrading a non-CDB and then converting it to 21C. You're going to have to convert to the multi-tenant architecture before you get to 21. And there are various ways to do that, and that's what we're going to talk about today. Now, when it comes to licensing, there have been some changes over the years for multi-tenant. Included in all of our offerings, by which I mean Standard Edition and Enterprise Edition, on cloud and on premises, you can always have at least one pluggable database. That was the rule for 12.1, for 12.2, and 18. One pluggable database with no extra license needed, regardless of edition. Long about a little over a year ago, we actually enhanced this for 19C to say that you can have up to 3 pluggable databases for Standard Edition or Enterprise Edition without requiring the multi-tenant option. And when we say 3 pluggable databases, we mean 3 user-created pluggable databases. So that's exclusive of the pluggable database seed, which we use for provisioning, and also doesn't count the CDB root. So 3 of your application or development or test pluggable databases without having to get the multi-tenant option. So this gives you a taste of consolidation and the advantages of multi-tenant without having to pay for that extra option. Now, if you don't want to get into the multi-tenant option, which means more than 3 pluggable databases in a container, you can set this system parameter, and that way no one will mistakenly create that 4th or 5th pluggable database, not realizing that it would take them into extra license territory. Because as we'll show you, creating a pluggable database is awfully easy. Now, in the multi-tenant option, if you are going to pay for that extra option and do really large-scale consolidation to take advantage of the things that we'll talk about, well, there are, again, some distinctions there. If you're on premises with Enterprise Edition on non-engineered systems, you can have up to 252 pluggable databases in a container with the multi-tenant option. And as I mentioned, that is an extra cost option on Oracle Database. If you're on Exadata or ODA, Oracle Database Appliance, you can actually push that even further, all the way up to 4K, 4,096 pluggable databases in a container if you want to. And the same is true in many of our cloud offerings, Exadata Cloud Service and the High and Enterprise Edition or Extreme Performance Edition in the cloud. Now, you might say, well, gee, will I really get more than 252 pluggable databases in a container. And in many cases, that might not make sense, but I can tell you right up front, in our autonomous environment, we often run with 300 to 800 PDBs in a single container because it provides so many advantages of economies of scale. Now let's talk about the architecture itself. If you're used to the non-CDB architecture, you can think of a non-CDB database as a single entity. Now, we know that within that entity, there are different subcomponents. There's schemas, there's table spaces, and so on. But what we're going to focus on here is that it will have its own memory associated with it. It will have its own set of background processes to run everything, your lock manager, your PMON, SMON, and so on. And then it will have its own set of files, your system and sysocs table spaces, your user table spaces, and so on. It will also have a set of redo logs, archive logs, flashback logs, and so on. If you have multiple databases on a system, that means you have multiples of every single one of these. You have multiple SGAs allocated for every one of those databases. You have multiple sets of background processes running, and of course, multiple sets of files, one for each database. And what this means is that even if one of those databases is completely inactive during some point of the day, maybe it's only active during business hours, or maybe it's only active at night when you're running batch processing, it still has that SGA associated with it unless you're shutting down and starting up databases all day long. Well, in the multi-tenant architecture, we get some economies of scale here because you start with a container database. That's your backplane of kind of in-database virtualization for Oracle Database. And the orange pluggable database that you see depicted there, that's our PDB seed that we use for provisioning. All the other pluggable databases are what we'll call application PDBs. And you can have many of them, as we saw, up to 252 application PDBs in an on-premises commodity hardware situation. So now, yes, you have your memory, you have your background processes running this container database, you have the sets of files, both the system and sysocs for every one of these databases, and you have one set of redo logs, for example, you have your set of flashback logs. But then as you add these application databases, you still have one set of memory, you have one set of background processes. And when this is sized for, in this case, 8 pluggable databases, what you're going to find is that the sum total of the memory needed to run those 8 PDBs is going to be a lot less than if they were 8 individual non-container databases. And that's because your individual non-CDB has to be sized for your peak processing load for every one of those databases. Whereas in your multi-tenant environment, you're generally going to find that when the first PDB is at its peak, maybe the 7th one is at its nadir of processing, and you can take advantage of that and size it. Generally, maybe start with a 30% less memory for your total SGA than you would as non-CDBs. Now, of course, you'd want to size it based on testing and knowing how your workloads interact, but you can generally get some really good hardware savings out of this. And on top of that, you get the ability to manage many as one in this architecture. You can back up all of these databases with one RMAN command, yet you can still restore individual databases to a single point in time, depending on your needs. So it gives you that economies of scale for managing databases as well as for using hardware. One of the ways we achieve that ability to manage many as one is that multi-tenant introduces a new layer of views in the container database. We're all used to, for example, user tables, which is all the tables owned by you as a user, all the tables that are visible to you as a user, and then DBA tables, which only those with DBA access would be able to see all of the tables in an individual database. Well, in a CDB environment, we introduce the CDB level of views where you would have CDB underscore tables, and that would list all of the tables in the entire container. Now, every one of those individual PDBs has its own namespace. So you could have the schema Scott with the table tiger, good old Scott.tiger, in every one of those PDBs. So in order to make this clear in the CDB views, we add a con ID column. That means container ID. If you're in a non-CDB, the con ID column is going to be 0. But if you have a container database, then the value for the container ID is 1 for the CDB root, 2 for the PDB seed, and then 3 up to 4098 for the individual PDBs. So that means that every instantiation of Scott.Tiger in one of those PDBs will have a different container ID associated with it. So you can see the entire view with the CDB tables view, but yet you can also then tell which table belongs to which pluggable database. I mentioned that you can have economies of scale in managing pluggable databases in a multi-tenant environment, and one way to do that is just in the way you manage and run your scripts that you have to run against these pluggable databases. To run a script against multiple PDBs, what you want to do is use catcon. It's a Perl script that is built specifically to run SQL against multiple pluggable databases in a container. So let's just say that you had a script that you use for monitoring all of your databases. It's maybe looking at free space or something like that. And you want to run this periodically and watch to see whether anything is getting tight on a particular table space or maybe even on disk space, who knows? Well, you could do that with a SQL script in catcon and run that one script just once to get the results for all 8 of your pluggable databases in this case. So again, that manage many as one allows you to do so much more with your DBA resources that you have available. That may be you as an individual, or it may be you as an organization. So I realize this was kind of a whirlwind tour through the overview of the multi-tenant architecture, but given that it has been around for 7 years, we think a lot of people have had exposure to it in one way or another. Hopefully this is a good refresher. And now let's get into how you can migrate into the multi-tenant architecture.
So thank you, Roy, for this introduction. Now let's go forward with how to migrate to the multi-tenant architecture. And we would like to keep it as simple as possible and go really straightforward. Later on in the presentation, we add more complexity to our environments. But for a start here, we need to create something. What do we need to create? A container database. Because we can't convert your current non-CDB into a container database. That does not work. We can convert your non-CDB then later into a pluggable database. But we need a container database first, so you need to create it. Now you could be one of the brave ones and say, I do it all command line. Then you make sure that you use this enable pluggable database statement, part of the create database statement. But we rather would like to recommend you using the DBCA. Makes life easier. By default, it's ticked on create as a container database. And when you follow this advice, you get a container database. By default, it will have the character set AL32 UTF-8. And this is also a strong recommendation because since 12.201, this allows you to plug in now non-CDBs as new pluggable databases with various character sets. So you can mix. One of your new PDBs could be Western European 8859P15. The next one could be Western European MS-Win 1252, and so on. So you can mix all the variety of character sets as long as your root container is AL32 UTF-8, and this is also the default. So just keep that. Then your container database by default since 12.201 will be created with local undo. So you see it on the screenshot, the box is also ticked on. If you would like to change the local undo by yourself, you need to bring the database into startup upgrade mode. Why do we strongly recommend local undo? Local undo is the requirement for all these cool features we have since 12.2. Hot cloning, flashback pluggable database, and much, much more. And we will highlight some of these features today as well. Then your pluggable databases, especially when there were non-CDBs before, and now they should become pluggable databases, and you plug them in, they may have different component sets. So when you check into DBA registry, you may find that one here, like my 3 examples, one has label security, the next one has spatial data option, and the other one has the workspace manager. Now, if you want to plug them in, the $CDB root like the docking station for all these PDBs, must be a superset in terms of the installed components in the root container. So when we plug them in now, the root container must have catalog catproc xdb, that's mandatory anyways, but it must have also workspace manager, label security, and spatial data option. If one of these is missing, then you can plug in your PDB, but it will never open unrestricted. So recommendation is install as many components as required, but not more than necessary. This has two important things or aspects. First of all, less components mean faster upgrades. That's one thing. Less components mean less scripts to run, upgrade runs faster. Very simple math. Second thing is, if you don't have certain components you may not use anyways, that means also you need to take care less on special patches, especially on the quarterly OJVM patches. So be careful and decide carefully what you want to install. It's always possible to add components later on to your CDB root if needed. When you create your database now in DBCA, we would strongly recommend that you tick that advanced configuration button. Don't go the easy route and click advanced configuration and then custom database, because this route is the only way how you will see this screen here, where you can choose which options you'd like to install. And at the end, create a template from this and then reuse that template, and it will do always the same. Now here you see by default, there are a lot of components ticked on by default on the CDB root. But be aware, if we do exactly what's here now on that screen, my CDB root will have all these options installed. The PDB seed won't have any of them. Why is the PDB seed so important here? The PDB seed is a read-only pluggable database we create, and we use that PDB seed when we provision a new PDB. As soon as you say create pluggable database, we will create a copy of the PDB seed. And now all these copies, like the sons and daughters of the PDB seed, they will have only the Oracle Server and XDB installed. This could be intended, and this is absolutely fine, because you can install also components into pluggable databases as long as like the mother component is in the CDB root, all is fine. You can do that, but you need to be aware what we are doing here. If it's not ticked on here for PDB, the PDB seed doesn't have that component. Another thing you need to be aware, if it's clicked on by default, Apex, which is a great feature. I love Apex, we all do actually, but Apex should never be in the CDB root. It should be always only in PDBs. And this is the only exception from the rule with the components. Apex can stand alone and should be standalone in PDBs and should never be in the CDB root. Why not? Because if you start unplugging and plugging in later on, you need matching Apex versions in the CDB root of the receiving one if you have it here in your root. And this creates all types of various problems and issues with versions or with non-existence and whatever. No Apex in CDB root, Apex always only in the PDBs, and this is the only exception from the CDB root, has to be the superset. And if you are in a situation that you realize, oh, we don't want that component, or can we remove it? Is it safe? You can remove basically more or less almost all components. You find a longer series on the upgrade blog. We linked it here, so when you download the slides, you have the link how to remove components from a non-CDB, from the CDB root, from the PDBs, or from an entire multi-tenant environment. Another thing to consider is compatible. Compatible should be always the default of the release. For 19C, that means the default compatible setting is 1900. So when you create with DBCA a container database, it will have compatible 1900. 3 numbers, leave it like that. There's no need for a 4th or a 5th number, even though you could set it. And don't set 19.1 or 19.3 or 19.6 or whatever. That just gives you trouble. Also, the typical question, should we increase compatible when we apply a patch, a release upgrade? No, never. Never with a footnote. There was an exception in 1910 when you would like to use a new feature which required that you change compatible, but do this only if you can change then compatible in your entire landscape. So keep compatible always the same in the release you're using. Don't have one database in 19C with compatible 19.3. Oh, the next one with 19.00. This just gives you trouble because when you unplug and plug, you need to be aware of the silent compatible change. In the example here, we have a pluggable database and it's in a container database where compatible is set 12.201. Now I unplug it and I plug it into a container database where compatible is 19.00. That works fine. When you study the alert log, you will find out, oh, there's a silent compatible change. I didn't do that. It happens because all PDBs will automatically adopt the compatible setting of the CDB $root. But now you see where this becomes tricky, because if this would be now 19.00 and 19.10, I couldn't plug backwards anymore, even though both are 19C container databases. So compatible, keep it equal in your environments for the release, and just the default value. Now on with Daniel.
Okay. Now that Mike has created our container database, let's move on. The next step is upgrade. If you need to upgrade your database together with your multi-tenant migration, it is our very strong recommendation that you first upgrade the database and then you plug in. The reason for that is very simple. With a database upgrade, you have very good fallback capabilities. If something goes south in your upgrade, you can simply just flashback the database. Whereas the conversion to PDB is irreversible. The second you plug in your database, changes are made to the data file headers, which can't be undone. So there's really no way back, which is why we recommend upgrade first and then you convert. Now we are ready to plug in our database. The first thing that we have to do is to ensure that our database actually fits into the container database. And we do that by generating a manifest file in our non-CDB database. The manifest file contains information about our database, and we can use that as input in our container database for the check plug compatibility function, which can tell us whether or not you will hit any issues when you plug in this specific database to this container database. After running the function, you should always query the view PDB plugin violations. Even if the function tells you that it's safe to plug in this database, you should always query the view to get much more details. The issues that are found by the function are grouped by severity. It can be either errors or warnings. Now, errors is something that you must definitely look at and fix one way or the other, whereas some warning messages are more like informational messages. It could be a database parameter gets automatically changed, or in this example here, I'm told by the database that I have to run the non-CDB to PDB script, but I already know that. But anyway, you should always query the view PDB plugin violations. Let me briefly touch upon the manifest file before we continue. We just created the manifest file, and in fact, it's just a simple XML file that is human readable. I mean, for those of us that do understand XML. But if you look at the file, you can see that it contains a lot of characteristics about the database, like, for instance, information about data files, services, parameters, and so forth. But very important, you should never make changes to the manifest file. The compatibility check is optional. You don't have to do it, but I would recommend that you always do it to find out in advance if there are any critical issues when you plug in this database to a container database. If you plan to rename your database when you plug it in as a PDB, you can check whether there are any issues with the new name in that container database. Now we are ready to plug in the database. The first thing that I have to do is to shut down my non-CDB database and restart it in read-only mode. Then I can regenerate the manifest file. It's very important that I regenerate the manifest file, and I do it while the database is in read-only mode. This is a prerequisite. If you have a manifest file that wasn't generated in read-only mode, you can't use it later on. After generating the manifest file, I now shut down my non-CDB database and I won't need that anymore. In my container database, I can now create a new pluggable database. I give it a name and I refer to the manifest file that I just generated. And that's it. In this example, the database will reuse the data files where they are located, and now you have created a pluggable database. But we're not all done, because we still have to convert it into a proper PDB. Now it's still just a non-CDB database that has been plugged in, but we haven't really converted it yet. So let's look at that. First, I open my PDB and then I switch into it. Next, I use the non-CDB to PDB script to complete the migration. Now I'm transforming my non-CDB database into a proper PDB. And when that completes, I have to restart my pluggable database. After that, I can query PDB plugin violations to determine if there are any issues that I have to attend to. Next, I'll ensure that the database is in fact opened in read-write mode and unrestricted. And finally, I can ensure that my PDB starts up together with the container database if it restarts by saving the state of my PDB. So let me sum up. Migrating to a PDB requires downtime. How much downtime do you need? Well, the answer is, as always, not 42, but it depends. Typically, it takes 10 to 30 minutes, but it really varies a lot. And if you have a database with tens of thousands or hundreds of thousands of objects, you should expect that the runtime is longer than that. But the good thing is that once the script runs to completion, you won't have to run it ever again in that database. You only have to run it once. But be advised, the process itself is irreversible. And we will talk about fallback options a little later. I've prepared a little demo where we can see how you can convert a non-CDB database to a PDB. My non-CDB is called DB19, but I would like to rename it to sales when I plug it in. First, in my non-CDB database, I generate a manifest file. I then switch to the container database, and I use the function check plug compatibility to see if there are any issues when I plug it in as sales. No, PDB is compatible, so let's go ahead. Wait. First, I have to query PDB plugin violations. There are some warnings that I should be aware of, but no errors, so let's just go ahead. In my DB19, my non-CDB database, I then shut it down and restart in read-only mode. Then I regenerate the manifest file. And finally, I shut down the non-CDB database for good. In my container database, I issue a create pluggable database statement. I give it the name sales, and I use the manifest file. And then I open sales. There are some warnings, that's expected. I switch into the sales container, and I run the non-CDB to PDB script. This will now complete the migration to PDB. After a while, it completes. Let's see, there it is. And now I have to restart my PDB. Close and open. And let me query plugin violations again. Most warnings are gone. There is still one, though, that I have to look at. But the database opens in read-write mode and unrestricted, so users can now start to use the database, and then I save the state. So it actually wasn't that hard to convert from non-CDB to PDB, but we have a lot more options to cover, and you can get much more control. But I'll leave it to Roy to tell us all the details.
Thanks, Daniel. As Daniel said, there are options when you're upgrading and converting to a pluggable database, and then there are also options that you might want to take advantage of different ways to get into the PDB architecture. So let's start with the ones that are available for the upgrade and plug case. The first thing is to think about whether you want to copy your data files or not. And if we start with the no copy idea, this means that we are not going to create a copy of our existing non-CDB data files, but we're going to use the existing files to plug into that pluggable database. So you'd start with your non-CDB, which has its system, sysaugs, and all your user tablespace data files. And then what you do is set that database read-only. We need to do that because when we run dbms pdb.describe to generate this XML manifest file, we need to know that we have a frozen state of the database, that we're not creating new files, for example, that would need to be plugged in. Then you shut down the database, go to your container database, which has to already exist. So this idea of creating a pluggable database assumes the pre-existence of a container database to plug into. And then we use the create pluggable database command. What that does is it reads that XML manifest file, which contains all the information about the file locations for the PDB and other information such as character sets and other important characteristics of that pluggable database. Even within this, you have a couple of options if you want to reuse your data files. You could leave them in place exactly where they are, in which case you would simply specify no copy as part of your create pluggable database statement. If, on the other hand, you wanted to move them, such as into a directory tree underneath that container database, then you could use the move command, which, as you know, on a Linux or on pretty much any operating system, is going to be much faster than creating a copy of those files. Auto upgrade automates this process entirely. All you need to do is specify that target CDB as part of your auto upgrade config file. By doing this, you will upgrade the database to the new version and plug it in as a container database, all with one command. You can also do this with the unplug, plug, and upgrade approach, where you have a PDB that is in one container database. It will then get unplugged, plugged into the destination container, and upgraded in that target container database. It does have a few more steps involved when you're going from one system or one server to another. And for that, I'm going to refer you to Mike's blog post on that topic. A few other things to know about the no copy option. One is that, remember, data files are getting reused. So there's not really a fallback mechanism to the non-CDB state. The only fallback mechanism, as you're going to learn later when we delve into that topic, is going to really be data pump to get back to that original state if you're using no copy or move. But the trade-off is that you're making this migration much faster by not having to copy your data files, and also you don't have to duplicate the disk space associated with the database. The other nice thing about this is you can actually migrate across platforms with this option. By reusing the data files, you can, as long as you're staying on the same endianness, such as going Solaris x86 to Linux or Windows to Linux, for example, you can do this on a same endian cross-platform migration, and that can be really helpful. If you want to see a demo of this with auto upgrade, you can watch it on YouTube. I'm not going to show that here because I don't think we need to add any time to this particular webinar, but we have this on our YouTube channel, the Oracle Database Upgrades and Migrations channel, of how to auto upgrade and plug into a CDB with just one command. So that's the no copy option, but because there's the no copy option, as you might guess, there is also the option to copy the data files when creating your pluggable database. So let's talk about that. The beginnings are very much the same. You start with your non-CDB and its associated data files. You set that read-only and create your XML manifest file, then shut down the database so that you can do the create pluggable database command. You have your pre-existing CDB, and when you create pluggable database, it uses that manifest file to create that pluggable database, but this time we're going to copy the files into a location where they will now reside for that pluggable database. We're not reusing your existing files. So we have to specify the copy option in this case. It is actually the default. And if you don't specify copy or no copy, then you're going to get a message saying that you at least have to specify file name convert. And that's because copy is the default for create pluggable database. So what does file name convert do? Well, it basically tells the CDB where to copy the files from the non-CDB to. because it can't copy them into the same directory. They would have the same files in the same directory. That wouldn't work. So you give it a new location. Now, the file name convert is a pure textual replacement in the path for the files. So this could be a subdirectory. It could be the name of the files themselves that is getting partially or fully replaced here. So be aware that you can play with that file name convert depending on whether you have a particular naming convention or directory structure in your environment. In Oracle managed files, you don't have to worry about that. And that's because an Oracle managed file has kind of an invisible set of alphanumeric identifiers at the end of the file name. So even if you think of it as being users.dbf, it's actually something like users underscore a bunch of alphabet soup.dbf within Oracle managed files. Also, along with copying data files, you can clone over a DB link to create your pluggable database. And one of the interesting things that maybe not many users know about is that you can clone a non-CDB, not just a PDB, but you can clone a non-CDB to become a pluggable database over a DB link. Just like cloning a PDB, this would use the network link using DBMS file transfer, perhaps in parallel, if you specify parallelism there, to move the data files to their new location. For this, the source does have to be 12.102 or later. So if for some unknown reason you still have 12.101 databases around, you can't clone those as a non-CDB. Now, auto upgrade, as you can imagine, will automate this process for you. Very similar to the upgrade and plug automation, with the addition of specifying the PDB copy option in your config file. So that could be a PDB file name convert, or file name convert equals none if necessary, or you could say PDB copy option equals no copy, as you saw before. Nice thing to know about the no copy option, first of all, is that your original data files are preserved in this case. And that gives you an immediate fallback if something goes wrong during the plug operation or the conversion from non-CDB to PDB. So that's really useful. That's usually why you would use the copy option. But the trade-off for that safety is that it's going to take a bit longer, and it's going to require duplicating the disk space for those data files. One of the nice things about copying to create that PDB is that you can do it across platform. So this means that you could, for example, clone a non-CDB from, say, Solaris x86 into a Linux container database as a PDB, and it would copy it over the DB link and pull the data files over. That will only work on same endian migration. So like Windows to Linux, Solaris x86 to Linux on the small endian side. You can't go cross-endian with it. Okay, so that is the two options for doing the upgrade and plug, or unplug and plug type of move, no copy and copy of data files. Now let's talk about some other ways of getting into the multi-tenant architecture.
Thanks again, Roy. Next option, data pump. I guess everybody is very familiar with data pump. We have a non-CDB here, we have data and much more in our database. Now, if you want to make sure that no changes happen afterwards, we need to stop the application, which is downtime. Then we start the data pump export. This could be a full export, could be a schema export. And at the same time, we created already a container database, same or higher release. Of course, lower release would work as well with the version parameter, but I don't think that this is the intention here. Then we provision a new pluggable database. It has a system and a sysaux table space. And once it is provisioned, takes a few seconds, then we can start our import. That's it. Very straightforward, very well known. We can take also a shortcut route, and a shortcut would start the same way here. We have downtime. We provision our new CDB with a PDB. And now we build a database link going from the PDB into our non-CDB. And then we start data pump on the network link, which means we start impdp, the import, on the container database side, and we pull everything over the database link. We don't write a dump file here. This goes also same or to a lower version. So source can be lower or same version. And it's very convenient. So data pump is a well-known and proven concept. Dump file on a network link has a few tiny restrictions, especially regarding their parallel capabilities, but the advantage is no dump file gets written. And generally, data pump is absolutely flexible and has a lot of powerful features. So it starts when you want to do a character set conversion. It's very helpful. Implement partitioning. Very, very useful. Change from old basic file lobs to secure file lobs, something we really recommend. You can do this with everything or just a subset of data. You can filter, you can transform, and so much more. And data pump is also a very well proven fallback option. So you can go backwards. The version parameter is your friend here, and you can go from higher to lower version, but only via the dump file, not via the network link. Network link works only same or higher version, but not to a lower version. Of course, data pump is not the fastest option, and it requires disk space if you go via the dump file. But it works cross-platform, cross-NDNS, cross-version, and you can migrate from basically all releases since Oracle 10.1 to 19c without upgrading, because the new PDB you provision is already a 19c and you import into it. If you would like to learn more about that and all the tweaks we are aware of with data pump and recommendations, scan now this QR code with your cell phone, because on March 25, that's pretty soon actually, we will have a migration strategies seminar where we really dig down into data pump. And now on with Daniel on transportable tablespaces. Daniel, your turn.
The next option is transportable tablespaces with incremental backup on top. The concept is we have a source database running on a lower version, and we want to migrate that into a pluggable database running on a higher version. In this example, it's 19c. In our source database, we have the system tablespace and the data tablespace. In a real situation, you would have much more tablespaces, but for simplicity, we just have two in this example. System is your system tablespace, and data, this is where the user data is stored. In your PDB, you only have the system tablespace because it's an empty PDB. There is no user data there yet. First, we create a level 0 image file backup, and we restore it into our PDB. And at the same time, if necessary, we convert it into the right NDN format. This you only need if you go cross-platform, cross-NDNS. Then you can do level 1 incrementals and put on top of that. And you can do as many as you like. For each individual level 1 that you perform, you will reduce the downtime needed at the very end to synchronize and get all the latest changes into your target PDB. So in a real situation, you would run this on a regular basis. Now we are ready to perform the actual migration, and we will start by setting the data tablespace read-only in your source database. Then we can perform the very last level 1 incremental backup and take the very last changes from the source database and put them into our target PDB. Then we can use data pump and full transportable export import to first do a tablespace plugin where we register the data tablespace in our new PDB. And then we can do the metadata transfer from the source database to the target database. So we get information about triggers, grants, indexes, users, and so forth. But the metadata import is really fast because we don't have to transfer the data. We don't have to recreate the indexes. They are there in the tablespace already. So it's just a metadata transfer. It's normally fairly fast. If this is something for you, you should visit this Moz node to get much more information and detailed instructions on how to use this approach. Also, we have blog posts and even YouTube videos that gives you a bird's eye perspective and even step-by-step instructions on how to use this approach. We have other options with transportable tablespaces, but today we'll focus only on the ones that use incremental backup on top. The fallback option for this approach is really, really good because we preserve the original database. If something goes south during the migration, you can just restart the source database, put the tablespace back in read-write mode, and you're good to go. It's a fast approach because the downtime we need is just the time it takes to perform the last level 1 incremental, apply it on the target, and transfer the metadata. And one of the really good features about this is that you can go platform cross-endian format and even from a lower version into a higher version. If transportable tablespaces is something that you would like to use, again, come to our next webinar where we talk a lot about migration methods. Finally, I would like to round this off with GoldenGate. Just a brief overview of the concept. We have our non-CDB database to which the users are connected and they put in new data. We create a new container database on the same or higher release, and we provision a new pluggable database. Then we take the data from our source database and import it into our new PDB. You can use data pump or transportable tablespaces. And then we start GoldenGate replication, which captures all the changes that are made on the source database and replay them in the target database. So when a user inserts a row in my source database, it gets automatically replicated to the target database. So the two databases are kept in perfect sync, which is also why at your will, you can simply perform a switchover and send the users into your target PDB. And that's all it takes. There is no migration because it has already happened. The data is being streamed into our new PDB. This is our true and only zero downtime option. If your database is so important that you cannot afford any downtime at all, this is the only option that you can use. Some of the additional benefits are that you can come from a lower version or even a cross-endian format. The fallback options are good. The original database is preserved. But what I really like about this method is that once you switch your sessions over to the target PDB, you can reverse the replication and send the changes the other way, so you can keep your source database now in perfect sync. So you have the option of falling back to the source database even after go live without any data loss. So we have no more migration methods to cover today, but to sum it up, we've created this matrix with the migration methods and the pros and cons of each of the methods. I suggest that you have a look at this matrix when you need to decide which method is best for your specific database. Whew. There are no more migration methods. We talked about how you can go to multi-tenant, but we also have to talk about how you can go the other way. So Mike, will you talk about fallback options?
So you have seen now how you can migrate to multi-tenant. But when we speak about migration, it's always a good idea also to think at least a few minutes about potential fallback solutions, especially for the migration to multi-tenant. So our example number one here is the very straightforward one we showed you at the beginning of this seminar. You upgrade, you plug in, you convert. And here we can go back to 11.204. So what do? We are now in 19C. And the default compatible setting in 19C in a CDB is 1900. How can we go backwards? What we could do is we stop the application. We create an empty non-CDB database in our source release. If it was 11.204, we created 11.204. If it was 12.201, we created in 12.201. And ideally, tip from our side, if that is your fallback strategy, you have everything in place already. You have still the home around, you have created that non-CDB database already waiting to be fueled up with an export, because now we start a data pump export and we need to use the version parameter 11.204 in our example. So we will export from that PDB, and data pump will create an export dump file in the version 11.204 format, so we can import it into our non-CDB. And that's it. Straightforward. But unfortunately, it may take a little bit longer, especially if this was an 80 terabyte system. So be aware, and then you may use Oracle GoldenGate on top to do the synchronization. One option. The next option here, our lowest release, which allows us doing that, is 12.102. So we came from 12.102 or higher, we upgraded, we plugged in, we converted. And here the trigger or the key would be that we created our 19C CDB, but in DBCA, we went to the advanced parameter screen, and there we choose not to create it with 1900, our CDB, we created it with compatible, in our example here, 12.1.0. So it's a 19C container database, but it has no local undo at this point because that didn't exist. We have a PDB, 19C. What will we do now? We create a CDB in 12.102 or 12.201, whatever our source was. And now we can stop the application. Then we run the downgrade script. It's called cut downgrade in the pluggable database. And once this is finished, we unplug and we plug into our source. Then we run cut reload, and then the downgrade is finished. Now you would say, oh, wait, I'm not back in non-CDB. You're right. You're not back in a non-CDB environment, but you are back in the old version, and the downgrade is very fast. Because when we do a downgrade, we can downgrade the entire CDB or the PDB alone. And when we run the cut downgrade script in the after upgrade environment and cut reload in the previous before upgrade environment, and we didn't change compatible, we may be back in 15 or 20 minutes because the downgrade is very fast. So this is a good option to go backwards, especially when your database is very big. But it has one real disadvantage here. You have a container database with compatible 12.1.0 after going to 19C. So first of all, this will not give you many of the good multi-tenant features. And second, you will need extra downtime at some point to change compatible. As we said before, compatible applies to all the pluggable databases as well. So you need to change it in the root container and then restart at some point. And special care on data patch, because if you downgrade, you need to roll back PSUs or bundle patches or RUs in this case manually. Moss note describing that. So a summary for the fallback. Keep in mind, move to multi-tenant architecture is always a migration. It's not an upgrade only, it's a migration. So a lot of our usual fallback techniques don't work. We can't downgrade simply. We need to have this go backwards, but only to a CDB, not to a non-CDB. We have no flashback to a restore point. And the only possible fallback options are data pump with all the restrictions of downtime, but very flexible. Transportable tablespaces would only work to the same version. GoldenGate, on top of that, very good for decreasing the downtime. Or as we've shown, the plug into the source version CDB, which is not entirely going backwards and doing a simple downgrade. It's going backwards into a same release, but a CDB. So be always, especially in this solution, very cautious with the compatible parameter. So spend a little time on thinking about the fallback. It's really important. And then finally, migration options. We want to go there really safely. And in order to do that, we need to avoid pitfalls. On the upgrade blog with that link on top here, you find a complete overview, and it's a longer read actually about all the different options going there. And all the different options have sometimes also drawbacks, or they have potential pitfalls. And this starts actually from unpredictable downtime, so you need to test those with non-CDB to PDB, especially when your dictionary is very large. And here we took a quick summary of the typical plugin issues we see. So one of the most common ones actually we have seen is that the non-CDB has more or different components than the CDB. So you either remove the components beforehand. If you figure out, oh, nobody's using that in a non-CDB anyways, then remove it beforehand, not afterwards, or install the missing component into the CDB dollar root. Another pitfall, and we come to the time zone topic later on in this presentation, is that the non-CDB has already a higher time zone value than the CDB, because there you patched already up to the maximum, and the CDB comes with the time zone version out of the box. Very simple workaround. You install the higher time zone patch also into the CDB's home. Time zone can't be lowered, so this is the only option here. Third, the non-CDB has a higher patch level than the CDB. So you upgrade to 19C, maybe 1910, but somebody created the CDB with 19.8. Then ideally you install the matching higher patch level into the CDB root, or you would roll back the patch from the non-CDB. Or last option here, what we saw also several times already, especially in warehouse environments now, the non-CDB has a different DB block size than the CDB. And this could be initially cause really trouble, but there's also a simple workaround. There's an initOra parameter DB underscore N stands for 8, 16, 32 underscore cache size parameters, and you set this in the CDB's SP file. And then you can plug in your PDB with different block sizes. These are the typical most common pitfalls. And if you like to dig more into this topic, please go to the Upgrade blog, because there we have summarized all these pitfalls. And we would like to help you really maneuvering around these pitfalls, or if you hit them, find a solution, how to avoid them, or what the best way out of that situation is. So a final summary, the last words, I wouldn't call them the famous last words, but the last words here for the migration. Every migration is an architectural change. It's nothing you just implement right now. You need to think about it carefully, and you need to plan it. It requires downtime. That's a fact. It requires a fallback. You should have that in place. And it always ends with a backup. So once you are there, keep in mind, you're now in a new architecture. So you need to take a level 0 backup, a complete image file copy backup, or whatever your strategy is. You need a backup. And with that, I think we go on from here.
So you can probably see that fallback strategies are an area that does require some level of special consideration when you're moving from non-CDB to PDB. Another area is for those of you who are using DataGuard for disaster recovery, the interplay between multi-tenant and DataGuard, especially during the migration process, is something that you really have to pay attention to. The main message is that it is possible to preserve your standby when you're migrating from non-CDB to PDB, but that it doesn't happen all by itself magically as part of the process. You do have to pay attention to this, and there are some manual steps that you're going to have to take care of. You don't have to rebuild your standby, so I want to make that clear. We can reuse data files, for example, but you may find that rebuilding the standby is actually your easiest option. So depending on the situation and whether you're moving to new hardware, for example, you might want to consider just rebuilding the standby. So we'll talk about all these different options. If you do have a CDB already that has a standby with, say, other pluggable databases in it, just be aware that you really do need to follow these guidelines if you're going to plug other PDBs into that container database, because otherwise what could happen is your managed recovery process will stop and your standby will no longer be in sync until you get your environment back in shape. Okay, so now let's talk about preserving the standby database and this is kind of related to the no copy and copy of files. So let's talk about reusing the data files, which in the benefit to doing this, when you're going non-CDB to PDB, we reuse the data files. Like I told you before about using the no copy or move options, your PDB will immediately be protected in your DataGuard environment. So here's the initial setup. Let's just say you have a 12.102 non-CDB. You've got maximum protection, and you got a pretty good geographic distance there so that if anything happens in one location, the other location's okay. Well, for auto upgrade, we can upgrade your data guard environment again with one command. And what would happen is you would get downtime on your production system. You would upgrade that with auto upgrade, and then your standby, once it's opened in the Oracle home, will be implicitly upgraded by the redo apply from your primary. Because what will happen is all of those upgrade actions that took place with auto upgrade are going to be contained in the redo that gets shipped to your standby. So it will now be a block identical copy of your 19C database. Now that's all non-CDB. So how does this play in the move to a CDB in a data guard environment? Well, what you would do in this case is you start with that 19C non-CDB, and now you have your 19C container databases already set up with a standby on the same system. That's very important because standbys want the same directory structure and locations on the primary and standby. So you need that created in advance. Then what we need to do is make absolutely sure that your production and standby non-CDBs are at the exact same SCN. And there's a hidden slide in the deck when you download it with all the ways that you can do that to make sure that they're exactly synchronized, not off at all. Then you do your usual set read only, create your XML manifest file, and a separate step if you're in ASM. On the standby, you need to create what is called an ASM alias list. Now, why do you need to do that? Well, remember when I talked about Oracle managed files before and how in Oracle managed files, the file name isn't really the file name. It's what you see as a file name, but then there's an alphanumeric identifier on the end of it. Well, in this case, with a primary and standby, those alphanumeric identifiers are going to be different on the primary and standby ASM instances. So that ASM alias list is going to be needed when we then do the create pluggable database command. Because what will happen then is that create pluggable database command gets replicated over the redo apply, but it's only create pluggable database. What has to happen is now your standby has to be able to find those files. And that's where that ASM alias list comes in. And it says, oh, okay, here's the user table space, and here's the alias on my standby. I plug that in as the user table space on the standby. So that's the steps involved in preserving your data files and plugging in as a standby. You can then convert to non-CDB to PDB afterwards, and all of those commands that are in non-CDB to PDB, including the recompilation and everything, that all those effects would be shipped as part of the redo stream as it normally would take place in DataGuard. So once you're done there, plugin's completed, you can enable your DataGuard broker, start your application, and you're on your way. So if you want references to this, I know that that was kind of high level. I didn't go through step by step of how to preserve the data files. We have a lot of detail for you. Peter Van Puynbroek, who's the lead product manager for DataGuard, has a nice blog post about how to do this. The MAA team, Maximum Availability Architecture, has their usual detailed treatment of it in a support note. And then Daniel has a blog post on troubleshooting this environment. One last bit I want to mention about this when you're creating a PDB in a standby environment is that temp file management in DataGuard. Temp files that get added after the standby is created are not handled automatically. So when you have temp files in the PDB, you would need to add those yourself. And there's, again, a Moss note reference to that. So that's a lot to talk about, reusing data files. So Mike, why don't you take over and talk about whether you want to defer the creation of the PDB and then maybe about creating or recreating a standby database.
Next option, we defer now the creation of the PDB under standby. So our PDB is protected as soon as the data files are restored on the standby. So on the left side, this is our source, our non-CDB. And on the right side, we have prepared now our receiving CDB as a primary, and we added already a CDB standby to it. Now I will plug in and I will use the command create pluggable database standbys none. This will lead on the standby side of my PDB that the PDB gets created in the dictionary, but no data files are attached to it yet. They are missing. Then I enter Armen, and in Armen, I do a restore pluggable database from service. And this will now restore everything needed for this pluggable database. Once the Armen part is finished, I enter the pluggable database and all the pluggable database enable recovery, and then it will recover everything necessary. That's it. You can read your entire process in this Moss note here, making use of deferred PDB recovery and the standby's non-feature in multi-tenant. Or third option, you plug in on your new CDB, and then once the plugin is done, you create your standby from your CDB with all PDBs. Of course, the CDB is protected from the point on when the standby CDB is ready to take redo and is completely in sync with your new production. But how do we act, or what happens when we use now data pump and we have a standby in place? In this case, that's pretty neat. It works absolutely seamless. You just need to make sure that you set standby file management auto. Even in 19C, this is not a default. In 21C, this will become the default. And optionally, you configure DB file name convert. Then you provision a PDB on your primary CDB. So you create a PDB, it will be created as a clone of the PDB$seed, and this propagates automatically to the standby side. And once the PDB is there, you can start your data pump import, and all the import information, all the creates and inserts, and whatever the import is doing will be flying over to the standby via redo applied to the standby PDB there. Or even table spaces get created automatically. So you see, that is simple, straightforward. And the same applies to transportable table spaces. Now we would like to transport into a new PDB, and we would like to keep our standby in shape. So I have my source. Let's say it's on AIX. I have my target environment, my new CDB with a standby, and I already created, maybe it's on Linux, I already created a fresh pluggable database, because this is the pluggable database I would like to transport into. So my table spaces, I have all of them here. What do? I restore my data table spaces to the CDB side, and I restore it also to the to the standby side. So it goes primary and standby. And once the files are all there, they are received, then to ease my life, I call data pump full transportable export import. So this will now import the table space meta information, and this information will come also over to the standby via redo apply. So the plugin operation will happen on the standby as well, and then full transportable export import will rebuild everything necessary. So you see, even that, very seamless, very straightforward. You just have to keep in mind that you restore your files not only to the primary side, you need to restore your files also to the standby side. And you find all this in the step-by-step processing of migrating non-CDBs to PDBs. In ASM file storage, there's a data pump full transportable export import with even incremental backups used here. And then finally, GoldenGate. So in that case, it's a fully supported configuration. We replicate to the primary database. So from our source to the primary database, changes then get applied to the standby via redo, as usual. We need an additional GoldenGate configuration to handle switchover failovers during the replication. That's a little bit, I wouldn't say tricky, but that needs to be considered. And new data files requires also, as usual, the standby file management auto, and optionally you configure DB file name convert. But I think this is a standard in a standby environment anyway. And then I think it's Daniel time again. Daniel on with multi-tenant and TDE, tablespace encryption.
Thanks, Mike. Now let's talk about encryption, multi-tenant and TDE. Especially with the cloud adoption, we see more and more customers start to use TDE tablespace encryption, and simply because it is a must. When you go to the cloud, you must encrypt your data. So the next applies to those databases that are already encrypted with TDE. If you plan on encrypting your PDB after the migration, you don't have to worry. This applies to those databases that are already encrypted. In this example, the data tablespace is encrypted with TDE. So how do we migrate? Well, first we have to set the database read-only like with regular migrations. Then we export the TDE keys to a flat file, and we can then generate the manifest file. Finally, shut down the non-CDB and switch to the container database. Now I can create a pluggable database using the manifest file, reusing the data files, and I can get the encryption keys by importing from the file. How do you do it? Well, you use the administer key management command, and you use export keys for exporting. Now, the encryption keys are sensitive information, so we can't put them in clear text into the file. That is why you have to specify a secret. The secret is a passphrase that the database will use to encrypt the information in the export in the file system. So the encryption keys are encrypted and exported to the file system. For security reasons, when you work with encryption keys, you have to specify the key store password. In your container database, after you have created the pluggable database, you can import the encryption key and again use the administer key management command. You specify the location of the flat file and you give it the passphrase. You use the same passphrase that you specified during export so that the database can decrypt the encryption keys and put them into the key store. That's very hard to say. And again, for security reasons, you have to specify the key store password. If you have encrypted databases and you go to 19c, I would recommend that you go to 19c or any of the later release updates when they become available. On 1910, you should be aware of this bug that I mentioned in the slides, and I would recommend that you get patches for it before you start to test the migration. In addition, there's a reference to a Moz node, which has really good details and step-by-step instructions with all the commands that you have to use. Also, when we talk about encryption, we have to talk about data pump. If you use data pump for migrating or fallback, it's very easy. Data pump has full support for TDE. It can export from and import to encrypted databases, no problem. And in addition to that, you can encrypt your dump file so nothing is compromised. When we talk about transportable tablespaces, if you stay within the same endian format, there is full support for TDE. You can go from Linux to Linux or from Windows to Linux with an encrypted database, no problem with transportable tablespace. But if you have to go cross-endian, there is no support for TDE with transportable tablespaces. So if you come from AIX and you want to go to Linux, you can't use transportable tablespaces if your database is encrypted. In that situation, you would have to decrypt the database, use transportable tablespace, and then re-encrypt. And finally, let's talk about GoldenGate. Well, that's very easy actually, full support for TDE. If you're interested, I have a, you could say, TDE full house example. This is from a customer that I talked to some month ago that had to do a migration with basically all the components, including TDE. But what was very interesting here was that the DBAs that had to carry out the migration did not have access to the key store password. Well, in this organization, for security reasons, there was strong separation of duties. So the operational DBAs didn't have access to the encryption keys, whereas the encryption admins didn't have access to the database. Could you do such migrations under those circumstances? The answer is yes, and if you're interested, read the blog post. There is no more fun with TDE today. The next fun we will have is with upgrades.
Well, of course, Daniel thinks that everything about databases is fun, but I think he's onto something here with multi-tenant upgrades, because multi-tenant gives you a lot of power and control over how you're going to perform your database upgrades. So let's look at that. One of the things that we can start with is that multi-tenant gives you options of how many databases you're going to upgrade at once. We can upgrade a container database with all of its pluggable databases with one command. That's your manage many as one, where you get the economies of scale in database management. But you also get the flexibility of being able to unplug and plug and upgrade individual pluggable databases. So let's talk about how that works, use cases for both. For the everything at once option, what we're going to do is we're going to upgrade that entire container database, the CDB root, the PDB seed, and all the application PDBs with one command. Now, when you do this, you'll start with a number of processes assigned to this, and the minimum will be 4. The maximum is limited only by your hardware, because we will default to CPU count for the number of processes used to upgrade that container database. If you're using the DB upgrade command, for example, at the command line, the default would be -N4 for the number of SQL processes used to upgrade your database. Within that, each pluggable database gets, by default, 2 parallel processes to upgrade within that individual container. So what this means is that if you say DB upgrade -N2, capital N is used for the number of parallel threads for each individual pluggable database. So the two capital N and little n play together to tell you how many pluggable databases will be upgraded simultaneously in your environment. You take the total number of processes divided by the number of processes per PDB. That's the number of containers we will upgrade in parallel. So let's look at a concrete example here. Let's say you use the defaults, which is DB upgrade -N4 -N2. What will happen is that we will first upgrade the CDB root with 4 parallel processes. That's your -n. And then when we get to the PDB seed and PDB1, what we will do is we'll do those 2 in parallel, each with 2 processes. So we're still using the 4 total, but we spread them over 2 containers. Then as each individual PDB finishes, the next one will start up. So even though conceptually we would think about this as upgrading batches of 2 PDBs at a time, it doesn't quite happen that way because we try to be more efficient. We don't want to wait, like say PDB5 here took a lot longer to upgrade than PDB4 due to the nature of its dictionary, the components installed, or what have you. Then PDB6 would still start up as soon as PDB4 was finished. So that's how it works when you're upgrading everything at once. And as you can see, you can scale your performance by devoting more hardware to it. The more CPU cores and memory available, the more we can do in parallel. And in fact, in our testing, we regularly test upgrading 252 PDBs on, say, a 64 CPU system where we're doing 32 PDBs at a time in parallel. So that's one option, and the everything at once option is really nice because it's convenient. You can upgrade all of your PDBs with just one command at the command line. But there might be times when you want to unplug and plug individual pluggable databases. Why would you want to do that? Well, maybe you've got one database that is ready to move up, and the rest of the databases aren't ready for the new database version yet. Maybe they've got application dependencies, or you just don't get downtime at the same time for every application that uses that container. What you would do in that case is you would start with a CDB that's at the higher release already, fully patched, fully up and running. Then from your source database, we would unplug, plug into the target database, and then run your PDB upgrade in that target environment. The nice thing about doing it this way is that unplug and plug is always faster than upgrading the same database as a non-CDB, upgrading the entire thing in a single tenant environment, or upgrading in a multi-tenant environment. So why is that? Well, it's faster than a non-CDB because so much of the infrastructure is already there in the container database. So upgrading a pluggable database is lighter weight than upgrading the same thing as a non-CDB. For the single tenant and the all-at-once multi-tenant cases, the simple answer is, in this case with unplug and plug, we're not spending the extra downtime to upgrade the CDB root or the PDB seed. So unplug and plug, especially if you can reuse data files or use the hot cloning functionality of multi-tenant, will make your upgrades faster. So that's the basics of how upgrade will work with a multi-tenant environment, but you might notice that I was using DB upgrade, the command line upgrade here. So Mike, why don't you talk about how we can use auto upgrade to upgrade this kind of environment?
Thank you, Roy. Let us go on with auto upgrade in this case, when we do unplug-plug upgrades. So we upgrade a single PDB. And you see it already in the animation. We unplug, we plug in, we run the upgrade. Sounds very straightforward, is very straightforward. And this gives us also a lot of flexibility. It requires a compatible target CDB. So when my source is on AIX and my target can't then be on Linux. And it doesn't allow me a seamless flashback database because I'm going really into a new database. We have another technique later on, refreshable PDBs. So what do we need? This is a short config file, but let me show you a demo. So we start off here, and let me show you the config file here in the demo. This is the SID of my source. This is the target CDB I'm plugging in, and the PDB. So this PDB1 is in CDB 12102. If we have more PDBs, we just use comma separated lists. And source home, target home 12102, 19C. Okay. Now I call auto upgrade with that config file and mode analyze. This will analyze now my source pluggable database, but it will do also the plugin compatibility check for me. So let's check here in the status log if there's anything we should be aware of. And the status log tells us version before 12.1, after 19, log files, but most important, the pre-check is passed and no manual intervention needed. Sounds good. Let's start off with a deploy. So deploy will now do everything. It will unplug the PDB and will plug it in and then run the upgrade. So you see, when I do a LSJ, the unplug plug has already been finished. The upgrade started. I get more information with a status command. So it gives me a summary of the stage. Now we are 3 minutes into the upgrade, all the log directories, and upgrading now already 6%. This goes forward. And after a while, the job is now finished. That's good, without any failure, but let us check. Let me connect to my CDB2. And in my CDB2, I check now for the existing pluggable databases. And here it is. PDB1 here in 19C, read, write, open, everything done, everything completed. Just one command in auto upgrade, all done. Very flexible, very simple, very straightforward. So if we want more PDBs, as I said before, we just use a comma separated list. If you would like to rename the PDB, you would use target PDB name, and now we have the sub attribute dot PDB1, which is the PDB name of the source. And I rename it here into sales. And I do basically the same thing if I want to use the copy option for certain PDBs. So copy option .pdb1, file name convert, and so on. And for various PDBs, I would just use various entries here. The current limitations here, in this case, it doesn't work in a data guard environment because all the things we showed you before are not protected at this point. So, and it does not support transparent data encryption. But we are working on that part. You can read all this on Daniel's blog, how to upgrade a single PDB. And another technique we are using quite often is refreshable clone PDBs. You can use it for upgrade testing, but actually you can use it also when you do your live upgrades. So the idea here is, I have my current system. In my example here in the middle of the slide, it's a 12.2, and my new DB system is a 19C. I would like to create now a refreshable PDB clone in my 19C environment. So I create a refreshable clone. Why am I doing this? It's still a 12.201 clone here. It's not a 19C yet. It hasn't been upgraded. But I refresh it, and I refresh it either at will or automatically. So the good thing is I can trigger this step as often as I want to. Assume that my source is several terabytes. So just cloning even a several terabyte size PDB takes a while. But I don't care, because once I created this as a refreshable clone, I refresh afterwards and I refresh again. So I'm not bound anymore to the involved downtime or lag. Actually, it's not a downtime, but it's a lag of the copy operation. And this means I can go forward on my production much, much longer, because I can repeat that refresh command here as often as I want to. So I determine the synchronization point. Now I stop my application at this point, and I do a final refresh, and I disconnect, so I stop the application. The PDB still is alive there. If I need to reactivate it, I could do that. I upgrade now my PDB with DB upgrade only, because it's a refreshable clone PDB, and then I open it. And that is pretty cool and very, very helpful, especially since your source stays there, but also because you determine that point. So synchronization point is in your hands. Restrictions with data guard, and no auto upgrade support yet, but this is coming. We are working on this. And I think now I call Scotty and ask for more warp power. So Daniel, can you help me with that?
Thanks, Mike. I have to say, I am a huge fan of refreshable clone PDBs. They are so cool. But enough about them today. Next is faster upgrades. We all want faster upgrades. How can you do it? Well, first, a statement. We know for a fact that during upgrade, CPU is a vital resource. So we started a benchmark. We provisioned a bare metal server in OCI, gave it 16 OCPUs, a ton of memory, the coolest and the fastest storage, 52 PDBs, all components, CPU count was set to 32, and we wanted to test upgrade from 12.102 and to 19C. What happened? This is a graph of the CPU utilization during the upgrade of the entire container database. It ran for a little more than 4 hours. And it's actually quite disappointing. If the aim is to use the CPUs as much as possible, I would much rather have the CPU utilization around 80 or 90%. So actually the white space from the red to the green graph, that's just waste. So can we make it better? Yes, we can. Let's look at the details. The first part of the upgrade is pre-upgrade checks and fix-ups. In this phase, we have to gather dictionary and fixed object statistics in CDB $root and in all of the PDBs. And that's really a lot of work. So our recommendation is that you gather those statistics in advance. You can do it up to 7 days before the upgrade. And if you do that, auto upgrade will simply skip gathering stats during upgrade. What is the effect? Well, we could save 12 minutes of downtime just by gathering stats in advance. So 12 minutes is good, but it's not enough. We want more. So the next phase is CDB $root. You can remove components, but that might be hard in CDB $root because we learned previously today that the amount of components in root has to be a superset of all the components in all of your pluggable databases. So if you have one little tiny pluggable database out here with one exotic component, you also have to have it in root. And in addition, we want to ensure that the upgrade of root runs with as many parallel processes as possible. If you use auto upgrade, it'll automatically take care of that for you. What was the effect? Well, if we removed all components from CDB.root, we could save 13 minutes of downtime during the upgrade. 13 is better than 12, but we want even better results. So we looked at the next phase, which is upgrade of the PDBs. Again, here you could remove components from the PDBs. That should speed up the upgrade, or you can try to play with the parallel settings of the upgrade. And we did the latter. First, we changed the amount of parallel processors from the default of 32, which equals the CPU count, and we changed it to 54. So we are now overloading the system. We are using more parallel processors than we have CPUs in the system. We know this will work because some of the phases in the upgrade is a serial phase. So even though the upgrade in a PDB has 2 or 4 parallel processors available, it'll only use one during that serial phase. So by overloading the system by using more parallel processors, we could save 26 minutes of downtime during the upgrade. And if you compare the two graphs of the CPU utilization, it looks much better in the lower one. If this is something that you find interesting, here's a pro tip. You have to increase the processor's parameter in order to do that. And you have to increase it dramatically. In addition, what happened if we removed all components from all PDBs? Well, it gives us a stunning reduction of 48 minutes. So by combining those two, we could actually save more than an hour during the upgrade. And we looked at the last phase, which is the post-upgrade checks and also the recompilation phase. Now the utlrp script is already highly parallelized, so there's really not much to gain in this phase, except for postponing the time zone file upgrade. But if you have to do it, you have to do it. To sum up, if you want faster multi-tenant upgrades, there are 3 things that you can look at: gathering stats in advance, overloading the system by allowing more parallel processors than you have CPUs, and removing components. That was all that we have to share with you about upgrades today. Next is time zone, and Roy will guide us.
It does seem appropriate that I get to talk about time zone patching today, since here in North America, we're still recovering from our hour of lost sleep over the past weekend, whereas Daniel and Mike won't experience that for another couple of weeks in Europe. But this is a topic that comes up because, as you saw in our first webinar in the series, time zone patching is its kind of own separate thing, and auto upgrade does handle time zone patching for you automatically if you want to. But let's talk about how time zone patching and multi-tenant play together. First of all, just like any database, a multi-tenant container database can have a new time zone patch applied to its Oracle home, but then you would need to also patch the containers itself, the CDB root and any PDBs, if you want to update the time zone versions. The PDBs do not have to have the same time zone version as the CDB root. So that's important to note. When you create a 19C container database, by default, it will have time zone version 32. Your PDBs do not have to be upgraded to time zone version 32, but it still might be a good idea based on business requirements. So when you upgrade, by default, auto upgrade will upgrade your time zone version for you, which means having a couple of restarts as part of the upgrade as we update your timestamp with time zone data types. This will happen for all of the containers that you upgrade as well. So especially if you're using the everything at once upgrade approach, all of that will be handled automatically. And just remember, you're going to see some restarts in there as part of that normal process. Now, if instead you say time zone upgrade equals no, you can still then go in and manually update the time zone for each PDB later using the usual usual scripts, the ones to count the number of time zone columns in your database, the ones that check whether a time zone upgrade is needed or possible, and then the ones that will apply the changes. If you want to run this with CatCon, you might want to get the latest patch from the usual MOS note, and then check with CatCon using that utltz upgrade check script. Now, when you do this, there's the -s parameter for CatCon, and little s and big S mean two different things. The lowercase s means run this check only in the system containers, which is CDB root and PDB seed. The uppercase S means run it only in the application containers. We really strongly advise you to do that separately, because we've seen if you try to do everything at once, there seems to be some level of conflict that goes on, and it really doesn't seem to run very well. So do two sets here, system containers and then application containers. Then if you want to apply the changes, you could use CatCon to do it, or you could do it manually by connecting to each individual PDB. If you do it with CatCon, again, I would do it separately, one for the system containers, because remember, when you update that CDB root, it's going to shut down everything. So you might as well get that out of the way first, along with PDB seed, and then update the time zone version in your application containers, because that way, when each of those restarts, it's kind of an independent operation and it won't restart other pluggable databases at the same time. If you want a summary of this and how to deal with time zone patching in a multi-tenant container database environment, of course, Mike has a very comprehensive blog post on it. It'll take you through all of the steps. It's very useful reading.
Now, you heard a lot about multi-tenant, all the different options to migrate, but let's do a real-world check with a real-world custom environment. And I would like to introduce you to Switzerland's most personal insurer and also the oldest insurance of Switzerland, Mobiliar Insurance, founded almost 200 years ago. We had done a lot of projects with Mobiliar, so I would like to show you only two of these projects. And the first one I would like to introduce you to is the project 2017, when we started upgrading from 12.102 to 12.201 with 337 databases. 82 of them were production environments. And we had already 8 container databases at this time, with altogether 350 PDBs. The number of PDBs per container database was restricted by the team to 50, mostly for administrative reasons, and also because of the limitations we had in 12.102 with multi-tenant. For instance, the startup of PDBs, when you took down the entire environment, was serial. So when you had like 220, it takes much, much longer. Then goal was moving from schema consolidation to PDB consolidation and have a PDB-only architecture wherever possible, except for a third-party application environment which doesn't support the multi-tenant architecture at this time in 2017. The motivation, the driver for that was really the developers, because the DBA team was so smart. When they gave the developers a CDB environment, they put also a small debug solution on top of it. And this debug solution allowed the developers to create a PDB by themselves. Now, while a database creation could have taken up to 2 days before, it took now a minute or less. And the developers liked that so much that they really wanted multi-tenant. Plus, if you want, you can give somebody more privileges in a PDB because it's more isolated. The cost savings for multi-tenant, of course, were a big driver, and also automation. When you have just a very small DBA team, and the Mobi team is a small, very skilled but small team, you need to automate as much as possible. Otherwise, you drown at some point. And this was possible with multi-tenant. So when we went there, we went to 12.2, the regression tests were done in the freeze phases of the software. We agreed at this time on a special release update. This was the July one in 2017. We had switched already before to a dual home strategy, and the upgrades to 12.2 were done with CAT-CTL-PL. So Mobiliar Insurance was also beta tester of our parallel upgrade tool. They included this into a homegrown shell script with, I think, 5,000 lines or something like that. And they have a performance warehouse. So the performance tests are done by the application owners. And whenever they find something, we can go back in many database environments for the entire lifetime of the database since it really got created, and find out how a specific statement has performed like 3 years ago if necessary. Now I show you one of the CDB upgrades, actually. Here we are on a Linux server with 3 terabyte of RAM and 32 CPU cores. So by default, auto upgrade chose 32 parallel workers, where 2 workers work on a PDB. So we have 16 PDBs going forward in parallel. At this time, there was no auto upgrade yet, but Mobiliar's shell script solution was one of the examples we built auto upgrade for. So the leading examples, we got that shell script and we learned from it and implemented a lot of the things into auto upgrade. At this time, we had to go the standard way. So pre-tasks with pre-upgrade char, and then the fix-ups, 13 minutes. Then the upgrade itself, now with -N32, create a guaranteed restore point, 5 minutes, then all in one upgrade, 2 hours 46, and 32 minutes for the recompilation, and then another 6 minutes to enable local undo, because as we said before, local undo is so important on 12.2. And then the post tasks, as we said before, you are now in a new environment, you need an immediate create level 0 backup of the entire container database. Took 10 minutes, then drop the restore point, and that's it. Altogether, less than 4 hours. Now try 50 database upgrades in 4 hours. No, it's not so, okay, with auto upgrade, you could do that if your machine is very powerful, but this is also very, very smart, actually. Now, were they successful? Of course, because we showed these slides at Open World 2017. Parallel upgrade unfolds the full power when you upgrade PDBs in parallel. And 50 PDBs in less than 4 hours, that's quite good. One very important thing to mention at Mobiliar, the big paradigm is really when we encounter issues, we fix them before go live. This is, we test thoroughly, and so far everything runs well. If you want to read more, the Mobiliar team has its own blog, so you can find everything on the Mobiliar database blog. I was on site the last time on 2nd of October 2019. And I sat together with the team and I asked them, how is your consolidation effort now? And they looked at each other, and then everybody had a big smile on their faces. And they said, hey, Mike, since yesterday, 1st of October 2019, we have reached 100% consolidation. There is not a single non-CDB anymore in our house. That is really cool and pretty smart. So we have seen, of course, a high number in increasing PDBs, mostly driven by microservice. So microservices get hosted in the PDBs, and that works so well. So a self-developed dbus interface allows to provision ALDE or even drop PDBs. Yes, that happens. And it had been used until today to create far more than 1,000 PDBs. This is really cool, actually. The next step, the next project was they got a Exadata environment, and we migrated with unplug and plug to the Exadata environment in big batch runs. That worked very well. But I would like to go to the last project we did together, the upgrade to 19C. Because we were on 12.2.1. And by the time I called it Project 2020, by the time we had now over 2,000 PDBs, the goal was we go from 12.2.1 to 19C. We have still limited a number of PDBs in production environments to 50, but in test and dev, we go up to 150. The constraints, we are a little bit CPU resource limited. So when we upgrade one of the CDBs, we can't take all the resources on the system because there are still production environments running as well. So the solution was we take CDB after CDB and upgrade everything at once. One DBA covers 1 to 2 CDB upgrades, and then once done, the next takes over. It's a small team, as I told you. And adopt auto upgrade. Yes, Mobiliar was again one of our leading beta testers of auto upgrade, and they tested it and used it, of course, not only tested it, but also used it in their production environments. This is the environment we were upgrading at first on a single weekend, 5 CDBs, the test and dev environment, with altogether 735 PDBs. And you see between 144 and 148 PDBs. And this is the logs from the upgrade timings from 4 of them. I don't want to hide the 5th one, but the logs got lost, so I can't show you that. And you see between 380 minutes and 444. So for each database, you get such a summary when you use auto upgrade. So you the setup, pre-upgrade, and so on. The biggest part, of course, underneath the second arrow line, DB upgrade with 279 minutes or 305 minutes. And then also the post-fix ups, which includes the recompilation. That takes also a little bit, but we were CPU limited here. So they were successful between 6 and 7.5 hours, including recompilation, and only 10 OCPUs were used per CDB. So this is pretty cool. And a few remarks, a few tips and tricks and hints. We had one post-fix up issue. And as we wrote on the upgrade blog several times, use the newest O patch, very helpful. Then also, as really there's a lot of power hammering on the database, it helps to use a higher process parameter setting. Now, you may remember from one of our upgrade seminars, you can pass on a higher processor setting only for during the upgrade to auto upgrade. And then it will revert automatically to the previous setting after the upgrade. So we increased it here. And then it's also really helpful when you recompile just generally in your PDBs before you upgrade. This helps you saving time because of forced recompilations. If you want to read a full story, again, this is the link to the Mobiliar blog. It's in English, of course, so you can read the entire story completely unmasked and transparent. And I think it's a fantastic success. So last words here for Alain Fourer. Alain is the head of IT database services at Mobiliar Insurance. And we upgraded 735 databases, pluggable databases in this case, on a weekend. And the task was mostly really relaxed. Start auto upgrade tool, monitor the progress from time to time. And sitting in front of the screen is really not necessary. So great team. Cool customer, really stepping forward. You should do the same thing.
So that's it. Mike, Daniel, and I would really like to thank you for attending today. We hope you found this session enjoyable and that it will be valuable input into your next multi-tenant migration.
Next, we will talk in depth about migration methods. As you learned today, some of those methods can even be used for multi-tenant migrations. So I really hope to see you next time.
As usual, we will be in the chat for a little while to answer all your remaining questions. Feel free to ask them. We hope to see you soon again. And until then, please take care and happy migrations. Thank you.